Good afternoon, ladies and gentlemen. Welcome to this TNO webinar on automated security operations. My team and I have prepared what I think is a very interesting webinar on this topic, and we will show you many interesting items in the next hour or so regarding how this new platform that we have developed can provide solutions to the challenges that organizations, security operating centers and CSIRTs might face today and tomorrow. We have a nice explanatory video for you, and we will go in more depth into the different pieces of the ASOP platform. We will also have a demo on the command line level, so please be aware that we will go from the really strategic overview down to the technical bits and back again. So please be aware that all these contents will come into place in the next hour or so. First, some practical guidelines. Please put your mute your mics and close off your video feed. We will have an interaction, different interactions moments actually, 4 times. And this is, I will show you when this is the case, and you can raise questions. Those can be done via raising hands in Teams, but you can also post them during the webinar in the chat, and this is moderated, so some questions will be answered directly, and some I would like to invite you to address during these Q&A moments. Please be aware also that this webinar is being recorded, and it will be posted on the TNO website together with the video in due time. And to make things practical, you can also in Microsoft Teams push on the 3 dots and seeing my screen and highlight it. So this studio will be available for you on the screen the whole time. Having said that, I want to introduce Nora El-Wachi, my esteemed colleague next to me, who will explain more about the ASOP goals. Nora, would you take over from me?
Thank you, Allard. So I'm Nora El-Wachi, the lead of the Consortium Automated Security Operations, ASOP. And today I will cover the following topics: the cyber perspectives, and in addition, our response to these current market challenges. So afterwards, we will be showing you the video, which will give an introduction to the platform for automated security operations. So now, first, I would like to cover the cyber perspective. Our society has become entirely dependent on digitized processes and systems. Our industries have been digitized very fastly, like the manufacturing, health, but also government. So the rise of the digital threats exploiting these dependencies go hand in hand. Next to that, the nature and severity of cyber threats has also evolved. Different challenges prevent organizations to actually develop viable approaches for this. And it has got to do with 3 challenges: data silos. So manual filtering became very insufficient at this moment due to the increase of data diversity and data volumes, like protocols, different sources, but also the way data is gathered. In addition to this, the limited visibility, so further investigation across endpoints, servers, networks, remains also a challenge for different SOCs. This also has got to do with the interoperability of applications, but also the dispersed solution of cybersecurity tooling. So finally, I would like to move on to the workforce. There is a global scarce of skilled employees. In conclusion, this brings us that we need a solution for the interoperability and automation of security operations. Finally, I would like to talk briefly about our response from the ASOP Consortium's perspective to these current market challenges. So ASOP Consortium wants to drive a holistic approach to automating security operations, and we would like to contribute to digitalize resilience of society and economy, and also improve the competitive strength of cybersecurity industry. and in addition strengthen the cybersecurity knowledge. We want to do that by developing the next generation cloud security platform and primarily driven by the problems of the end users facing with the current SOCs. And of course, also intended for managed service providers and vendors. This should enable the automation and orchestration of security operations and also support the ease of integration of vendors with their tooling and of course adapt to new cybersecurity challenges. So in short, the ASOP consortium wants to support interoperability with the development of the automated security operation platform and also in extension solve the vendor lock-in. So now I would like to wrap up my introduction by showing you a simulation of the video which shows the proof of concept which showcases the loop of automated response.
In our society, the rapid digitalization of critical sectors brings a lot of opportunities. But digital threats exploiting these digital dependencies increase with the same speed. More and more cyber attacks are automated to such a degree that they can be executed at machine speed. This results in systems being compromised within seconds, while the average time to discover a security incident typically lies in the order of weeks or even months. This timing imbalance creates an enormous workload for security analysts. And with the growing complexity of ICT infrastructures and soaring amounts of data, an analyst's workload is likely to increase even further. So to properly defend our systems from cyber attacks, we need fully integrated and automated cybersecurity solutions. The Automated Security Operations Platform proposes a blueprint for automated defense at machine speed. Designed with an open, modular architecture, this facilitates interoperability between different products, even from different vendors. ASOP has already developed the first high-level automated security prototype that actually works.
I see ASOP as a strategic answer in an effort to reshape the cybersecurity domain by automating cybersecurity processes to defend our ICT networks in a better, in a faster and in a more efficient way. As TNO, we cannot do that alone. You need different partners with different viewpoints, with different knowledge and technologies behind it. To also understand, okay, what kind of different threats are there, how do we develop this, how do we integrate the different solutions that are out there and work this out in a platform.
We can benefit by collaborating with other specialist cybersecurity vendors who make tools for managing cybersecurity risks, but also collaborating with customers who can articulate their needs and the challenges they face so that together we can actually come up with the best holistic solution for managing this in an efficient and effective way.
Together with the organizations that have knowledge of security services. You build a technology, but you do that with a basis and a knowledge of the threats out there that you want to address.
So there are three phases or three modules, if you wish, in PPS ASOP. The first one is monitoring and detection. The second one is decision making, and the third one is execution. They complete a cycle. We implemented a specific scenario. We created an emulated enterprise network with laptops, servers, routers, firewalls. And inside this network, there is an employee who starts an unauthorized VPN, virtual private network. And this is forbidden by the company policy because, well, you don't know what kind of traffic is sent. So the first phase, monitoring and detection, constantly looks what is happening in the network. It checks for any anomalies, any irregularities. It works using multiple sensors. They can be signature-based, they can be artificial intelligence-based. If it finds a sign of this forbidden connection, then the output of these sensors is combined, and then it can issue an alarm. This is carried on to the second module. The decision module picks up this alarm, but also enriches this information with, for example, business context, and checks what kind of asset is compromised. Is it a CEO laptop or is it some kind of backup system? Depending on how important this asset is, the optimal decision is made. So suppose the decision is blocked immediately. This signal is sent to the programmable infrastructure. This decision is then to be executed. The execution module has to actually install a new firewall rule somewhere in the network. All those operations are done at machine speed. There are many innovations in PPS ASOP. ASOP architecture is modular. You can exchange the modules. For example, if you have a monitoring module, you can easily plug it in to PPS ASOP. You can also mix and match commercial proprietary solutions with open source. You can create your security infrastructure tailored to your needs.
The unique benefits for Cisco, which the ASOP project is providing, is aspects like business impact. We are very good in determining what's happening on the networks, on the systems, on the data, but what is the business impact of that? How do you prioritize real-time, online? This is important, but that is more important, and that can wait. And for that you need, of course, the business impact of what you see, because business is leading to prioritize what you should do first. So that element of business value, business impact is very interesting for us to incorporate in our platforms as well.
Human experts are less burdened with all the incoming signals. They have much less tasks which are boring and tedious. Those things can be automated out by PPS ASOP technology. What remains for the human should be really meaningful piece.
ASOP's ambition is to ensure a secure and robust society. Our game-changing integral modular platform for security operations makes it easier for the entire chain, from developers to end users, to repel cyber attacks actively. Only through independent knowledge development, we strengthen the competitiveness of the regional cybersecurity sector at a global level. The consortium creates an ecosystem where R&D and market experience go hand in hand. ASOP innovates on interoperability and facilitates a new and fully integrated state-of-the-art technology platform for end users, MSSPs and vendors, which will be made publicly available. The ASOP consortium has the ambition to grow into the knowledge center for automated security operations within 5 years.
Yeah, thanks. You've seen the video. First, before we go into the more details, I want to talk a little bit about strategy. Actually, the strategy of the ASOP platform, a game-changing innovation platform. And to talk about strategy, I want to use the approach from Simon Sinek, the golden circle, which explains the why, the how, and the what. Well, first starting off with the why. So the why are the SOC challenges that my colleague Nora already explained. This is about the data and the data silos that exist. It's about the technology. It's about the lack of experience to workforce and the overwhelming information. So if you take it from that and to look at the what, this is the ASOP approach. So we are developing a platform that wants to automate cybersecurity processes, that wants to orchestrate them in an approach which uses modules. So a modular approach that helps to automatically generate incident response loops. And these modules are interoperable. They are open source based, but they can also be intertwined and interchanged with proprietary tools. So it's a vendor agnostic architecture that we have developed, and you can fit to the needs of the end users or the managed security service providers that will be using them. So how do we do that? Yeah, well, that's actually the ASOP platform that was just shown in the video. And you see this, these three elements, and we will dive into these three elements piece by piece. Doing so, we will do it from the first part, which is the infrastructure part, and we later go on to the monitoring, detection, and the automated decision-making part. But starting off with the infrastructure part, programmable infrastructure, I want to head over to my colleague Piotr, who is next to me. Piotr, could you please take us away into the infrastructure part?
Thank you, Allard. Hello, everyone. Thanks for joining. I'm Piotr Raniewski, Senior Scientist at TNO Networks. I would like to do a bit of a deep dive into technical aspect of PPS ASOP. So, first, the general architecture. There are a number of elements that constitute ASOP. It's a modular architecture. You see a lot of pieces. Let's say three main modules were already highlighted. At the very bottom, we have infrastructure, programmable infrastructure. We have monitoring and detection module. Next to it, automated decision making. But there's also this infrastructure abstraction layer in between them. I would like to tell you a little bit more about those elements. So, programmable infrastructure. You can ask why use it. What is this? Well, consider cloud. Consider a situation where you can program your system. Software-defined networks, software-defined storage, containers, virtual machines, bare metal, you name it. It's a very powerful concept. You can change it, you can reprogram it in runtime, which from security perspective means you can react to the threats, and that reaction can be at the machine speed. So as good as it is, or as powerful as it is, we have to admit that it's also not that easy to use. The reason is you have multiple vendors, you have many cloud backends, many APIs, proprietary solutions, open source, standardized, not standardized. There is really a lot. It's a very, very rich ecosystem. So we in ASOP would like to make, let's say, life easier. Let's assume that we have all those different cloud backends. But if we can make it agnostic to security operation center, that would be great. If we had like standardized open APIs, if we could make it such that the architecture is modular, that you can plug in your module if it only adheres to the published API, that would facilitate multi-vendor setting, that would also help in innovations. So let's look at programmable infrastructure and how it interacts with other modules of PPS ASOP. As it was mentioned, we already developed like a first proof of concept of ASOP to show that we can close this full cycle. That specific scenario is about unauthorized VPN. However, the architecture is so flexible that you can think of multiple other use cases, multiple other scenarios. Anyway, we have this user that starts a VPN connection from inside enterprise network. There can be various obfuscation techniques to hide it. How ASOP elements work together to handle this incident? First of all, monitoring and detection. We have to know what is happening in the network. So this is where infrastructure and monitoring and detection modules work together. Of course, we have to gather data from your infrastructure. You have to send it to some kind of collecting modules. Then you need to make sense out of it, right? There's an ample of data. You need probably various types of detectors. They can work at different levels, different layers. You can also combine them. There is no one detector that can do everything. And ultimately, monitoring and detection module can send an alert if there is enough evidence, there is something going on, handle it to automated decision-making module. Here we have information from, let's say, technical layer, but also there is this business context. There is a question, what will happen to my enterprise if my best action to take is to shut down the main server? Maybe that will not do any good to my business. So there are various options. You can just block things, you can continue monitoring, you can do many other things. This module is responsible for choosing the option that is optimal. Then it instructs infrastructure, this action needs to be taken. At the same time, as we said, well, there are many backends, right? What we would like to have is that the decision that we make is expressed in a kind of infrastructure agnostic way. I don't know to which cloud backend I'm talking to. This infrastructure abstraction layer should pick it up and make the actual translation. So from the very generic command to something that is really cloud backend specific. Of course, you need some kind of translation modules for that. You need to understand what is the infrastructure underneath, but we want to hide this complexity from upper layers. Finally, the programmable infrastructure receives the signal and actually it executes this action. So it can, if I can summarize it, be said that there are several innovations regarding programmable infrastructure. Well, first of all, this execution of commands at the machine speed, the modular design which facilitates interoperability, which helps us to mix and match solutions. We would like to go for open standards, open source, be vendor agnostic, but also allow proprietary and vendor-based solution to just plug in. As I said, we built the first proof of concept of the full cycle of PPS ASOP. We built it in on-premise in our TNO research cloud, being it at this moment a Kubernetes-based deployment. More details will follow later.
Thanks, Piotr, for this excellent explanation of the programmable infrastructure. We know we are now at the first part of the question and answers round. So if you have a question regarding the element Piotr just explained, please raise your hand and we will address it. So, meanwhile, Piotr, I would like to ask you a question. So, taken from an architectural perspective, what type of network architecture would benefit the best from this approach you explained? So, is this a local network solution? Could it be on-premise, a full cloud, or a hybrid solution?
My answer would be all of them. The ambition of ASOP is to also abstract certain things. So as an enterprise, you may want to choose different network solutions. You can start on-premise, then move to hybrid or move to public cloud. What would be nice is that you take this security solution with you, that it works regardless of what is underneath. That's our ambition.
Okay, thanks for your answer. If there are no questions at this moment, we will go on to the next. Oh wait, there is a question coming up. Let's see. I see Taco Vader has a question. Taco, could you unmute and put on your video and ask the question yourself, please?
Yes, sorry, I'm in the car, so I won't be turning on my video. I'm doing this by audio only, but my question would be, what's the main deliverable for ASOP? Is it developing the protocol, or is it making sure that the modules are created, or what's the result you are going for?
Well, the result is a prototype of the working system. So there will be several modules. Each module will let's say, deliver its own piece. So, for example, there may be a new detector, there may be workflow to react to specific threat, and this abstraction layer, which allows us to glue together many things and to mix and match. So we want to publish APIs. We want to provide an information what is needed if you want to connect your module, your product, your software to PPS ASOP.
I hope that answers your question.
Okay, thank you.
Yeah, thanks, Taco, for the question.
Yes.
I want to head over to the next question from Peter Janssen. Peter, could you put on your mic and your video feed?
Yes, hello. I will not turn on my video as I'm in the car like the previous question asker. My question is, and I really like the presentation and the approach. My main question is that we would regard ourselves as one of the players that would connect and provide data to such a system to assist in decision making. But we already do it with existing SOAR solutions. I'm trying to position this versus or in addition to the SOAR solutions that are on the market already.
Verlaat de vergadering.
I will answer it briefly. In a few minutes, my colleague will zoom into automated decision-making module where SOAR is actually one of the elements. So, in fact, we want to look beyond security orchestration functions. We have an ambition to say no matter what kind of infrastructure backend you are using, whatever SOAR produces can actually be executed. We also want to address questions about how to detect things, how to combine detectors. And my colleague, Irina, in a second will also answer that question in more details. So it's bigger than SOAR.
Okay, thanks, Piotr. I hope that answers the question. I want to end the question round part 1 for now and head over to the next speaker. So spare up your questions for the next part, please. Thanks, Irina, for joining. You're going to tell us something more about monitoring and detection part, right?
Indeed, yes. Thank you, Allard. Good afternoon. Thank you, everyone, for joining this webinar. My name is Irina Kiskop, and I work for the Cybersecurity and Robustness Department at TNO. I'm a scientist, and my research focuses on intrusion detection. Today, I want to explain in a bit more detail what the monitoring and detection module in the ASOP infrastructure does. So first of all, why do we have such a module? Well, the main goal is to basically achieve a false positive reduction in order to enable automated security. And what this means is that we're trying to detect incidents as accurately as possible in order to allow the SOC to provide an automated response. It is most events that we need to provide have to have a high confidence score. So we need to be fairly certain that they are truly security incidents. Our approach is based on 3 key ingredients, let's say. The first one is that we want to combine multiple data sources. And the reasoning behind this is fairly simple. The more we know about the underlying infrastructure, the better we understand how different, let's say, alerts relate to each other and what they actually say about the infrastructure. And examples of these data sources are flow data, so NetFlow, DNS logs. You can envision here firewall logs, security logs, process information, and so forth. The second aspect is that we want to combine both signature-based and anomaly-based detection methods. Now, signature-based methods rely on basically known patterns in the known threats. So we can basically recognize known attacks with high precision by using these kind of signatures. And a signature can be, for example, a domain name that's well known to be used by malware, or a block list of IP addresses. And this is just a few examples. On the other side, we want to use anomaly-based methods in order to detect new threats that we have not seen before in our environment. And for that, we basically need to sort of try to determine a normal behavior of our network or of our hosts, and then detect any deviations from that baseline. Finally, we want to fuse and correlate alerts, and that is with the goal of enriching the contextual information. Because our goal is not only to provide an alert to the SOC, is also to try to tell as much as we can about where did it happen, when, and possibly, how. So that is the idea. On the figure, in the figure on this slide, you basically see a representation of the monitoring and detection component as it is now. So you will see basically we have two sets of detectors: the signature-based and the anomaly-based. These detectors are fed with the NetFlow and DNS data at the moment. And what they do is that they provide, each detector provides a certain list of events or alerts. And these are processed in a simple module that computes a confidence score. And then based on this confidence score, basically the alerts with high confidence scores are further reported to the automated decision engine. In the future, basically the component that correlates the alerts would be replaced with some more machine learning method and will become eventually a proper correlation engine. As for the detectors, so how they actually work, if we look at the use case that my colleague Piotr defined earlier, so we're looking at unauthorized VPN connections. And for the signature-based detectors, we've tried to use, let's say, information about how well-known VPN services work. So, for example, we're looking at the case of OpenVPN, and we know, according to the manual book of OpenVPN, that this VPN client listens on port 1194 using the UDP protocol. So we will use this as a pattern for the NetFlow. In sort of a similar line of thinking, we are looking at DNS queries that involve the term VPN or even VPN installation, because those are quite suspicious in the sense that whoever is querying such domain obviously wants at least to gather more information about how to use a VPN service. So these are our two signatures. And for the anomaly-based part, we have basically made a list of relevant features based on both NetFlow and DNS. And you see here some examples, some number of unique connections, number of DNS queries, a number of flows, and actually many others. And we try to monitor these over time and observe deviations from the expected behavior. And how did we actually come up with these features? We first ran some tests on a public VPN dataset that was built for research purposes, and it's this dataset ISCX VPN 2016. And it's perhaps good to mention that it's the only dataset of its kind. So literature on VPN detection is also very scarce. What you see in the figure, I included an example of how we could use one of these features for detection. You see there's a blue curve, and this marks the number of flows aggregated per minute, I think, for a specific host. And you see the host is pretty active. And at some point, this number of flows drops to 0 between the vertical lines that are marked. That can be explained by the fact that there's a VPN tunneling active in that interval, which actually hides all the traffic from the router. So this is why we no longer see any flows coming in. And this is a strong indicator for VPN activity. Now, when we detect such a, let's say, event, we report it, and we report it together with its confidence score, defined basically in terms of the standard deviation. So we look at how much does the observed traffic deviate from its mean that we pre-computed. So what we've achieved so far in the project is that we implemented all the mentioned detectors on both DNS and NetFlow. So we have a proof of concept that actually collects all this data and is integrated the detectors. And we have demonstrated to basically it's able to detect OpenVPN usage. So we had a client that was setting up an OpenVPN connection. In this process, we also encountered some challenges. As I already mentioned, yeah, public data sets for research on this topic are essentially not very common. There only exists one. And in the current ASOP infrastructure, the traffic of the pods does not yet fully resemble, let's say, the workstation activity that you would expect in an operational network. And that will be improved in the future. Because we were very thrilled with the results so far, we have many future plans. And these include, of course, creating even more detectors using machine learning. So we already have a decision tree classifier and an autoencoder made, but they still need to be added to the infrastructure. And ultimately, we want to create the event correlation engine based on a Bayesian or a belief network in the first step. So what we're trying to converge is something like in the figure, in which, depending on the use case that or like the threat that we're trying to detect, we start by modeling, let's say, creating some sort of tree of events based on expert knowledge. And then we design specific sub-detectors, and the results of the sub-detectors are correlated with a proper engine. And the nice thing of this approach is that let's say the red block with the expert knowledge representation, that can be extended not only to VPN detection, but to any kind of threat or malware, or we can even map it to tactics in the MITRE ATT&CK framework. And the sub-detector set can be enriched with existing solutions, so we can easily plug in additional detectors. Finally, to briefly mention the important innovations in this component, our approach will enable detection with low false positive rates, and that allows for automated response. The framework that we created can handle heterogeneous data sources efficiently, and then that basically overcomes the problem of data silos. And the fact that we already have let's say, a concrete idea for a correlation engine allows for more visibility and explainability of the alerts going into automated decision engine. So this was my presentation about the monitoring detection part. Yeah, thank you.
Thanks, Irina, for this very well explained part about monitoring detection. Shall we look at the questions and see if we can detect an anomaly question in the audience out there?
Yes.
While you think of it and raise your hand, I already have a question I would like to pose. Could you explain a bit more about the types of data you would need to make best use of either the signature-based or anomaly-based detectors?
Yes. So in the current proof of concept, a minimum requirement is to use at least the NetFlow and DNS. But depending on either what the data sources that are available are, or on the goal of the detection, that can be enriched with any type of logs, and also with information such as process IDs, execution of certain files. So in short, the more data, the better.
Yeah, understand. Thanks. Okay, I already have some questions from the audience. First, Yusuf Osturk. Could you please put on your mic?
Hi. You can hear me, right?
Yeah, I can hear you.
Hi. If it's okay, I have two questions. One of them is about the input. How do you get the NetFlow and the DNS logs? I mean, do you do that part, or you will just input a monitoring product already into the system?
So no, we have components in place for collecting these data sources ourselves.
And the second question is about the correlation engine.
Yes.
Can we do queries on top of that, or do you just do like automated correlation? Also, what will be the time frame for the events? Because NetFlow actually sends like billions of flows, especially in the large network. So what will be the time frame, like a day or a month? What will be your plan for this?
Yes.
And yeah.
So in order to build a good correlation engine, we actually also required label data. So you need to sort of simulate at least some minimal threats on top of your own data sources. So I would say in order to make a correlation engine that as a minimum viable product, you would probably need at least some weeks of data. So I would say 2 weeks to a month would probably already get you a pretty good image of what the normal behavior is. But then again, this interval also needs to take into account specific patterns in the organization at hand, because there's obviously differences between summer months and when everybody's on holiday and the rest of the year. So those kind of things also need to be taken into account.
Okay, thanks so much.
Thanks for your question. Another question from Joey Dreyer. Joey, could you ask your question yourself?
Yeah, that's okay. I guess you can hear me okay.
Yep.
It's a bit similar question compared to what Peter Janssen asked previously, because this sounds somewhat similar to already existing log management and SIEM solutions. So how exactly is this going to be different? Because part of it is, well, log and event ingestion, which is already a component there, and also the correlation and data modeling as well. So how is this exactly different in that regard?
Yes, this is an excellent question, actually. So the correlation is, event correlation is something that is, let's say, traditionally attributed to a SIEM solution. But if you look at current SIEM solutions, they only mostly do similarity-based correlation, which is matching a timestamp and an IP address. What we want to do is actually allow some sort of semantic reasoning. That is, we define certain states of the network that can be described with the anomalies that you find. So we do not only want to say we have an alert, let's say, in the NetFlow data at a specific timestamp, because that doesn't say much. We want to say we have found a number of deviations in the flows in this time interval. And in the same interval, we also have something going on with the DNS. And together, they might explain this specific step in either the threat or the network at hand. So we are trying to actually build something much more complex than just matching different aspects like IP addresses and timestamp. And that requires a lot of knowledge as well, domain knowledge and knowledge of how the threat is, what kind of tactics that threat is following.
Okay, clear, thank you.
Thanks for thanks for all your excellent questions. Actually, I want to conclude this Q&A part 2 right now and head over to the next speaker, if that's okay. So thank you again, Irina, for your good talk. And I want to introduce my colleague Sebastian, who will talk about automated decision making. So Sebastian, take it over, please.
Thank you. Hi, my name is Sebastian Teesink. I'm a security researcher at TNO, also at the Cybersecurity and Robustness department. And I'm going to talk you through the automated decision engine that we created for this PPS ASOP project. Basically, what an automated decision-making engine is trying to do is have a look at what situation is going on within the infrastructure, take into account what type of anomaly was detected, and also look at, okay, what options do I have? What type of countermeasures can I apply to this infrastructure? And we did this using the following components of automated decision making. The first one is the security orchestrator. The security orchestrator is more or less the glue between all the components. So it creates a workflow, starts with one component, asks a certain question to it, receives a response, and based on that response, we'll take on the next step in the workflow. In this project, there was a question earlier about the SOAR product. We use Shuffle during this project, an open source SOAR, but our aim is to be able to also replace this security orchestrator with a different one if needed. Then the second component is the business impact analyzer. The third one is the course of action generator, and then finally we have the OpenC2 producer. And I'll get into the final three of them in a bit more detail. First of all, the business impact analyzer. This component tries to make sense of the current situation, so it creates situational awareness. First of all, it takes a look at the type of incident, what IP address was involved in this, and the confidence score of the monitoring and detection component that Irina showed earlier. Based on the IP address, it looks into the infrastructure model. So it looks at the infrastructure that Piotr discussed before, the programmable infrastructure, and looks at the business risk of the asset. So what type of confidentiality, integrity, availability, and privacy is involved here? Is there PII data on this asset or sensitive personal information? Based on these settings, on this factor, it will take its decisions. In future versions, we'd also like to, in this phase, these labels were applied by hand to the assets. You could also use a template for doing that. In future versions, we'd like to automatically assess these labels based on the business processes and business functions. So we'd like to map those on the IT infrastructure and derive these risk terms automatically. Second of all, we'd like to take into account the attack phase. For this one, it's an initial attack, unauthorized VPN connection. But what if this was a lateral movement phase? If monitoring detection would detect that, we'd also look back into our infrastructure. Okay, so how did the attacker get into the first place? Then we have the course of action generator. This one is going to look at what types of actions are available in this infrastructure. We limited ourselves to allow and deny a firewall, start and stop the instance, the asset, or do further investigation on this node. The course of action generator takes all this information into account. So again, anomaly information, infrastructure information, and all the countermeasures, and then decides what is the best option. It tries some of the countermeasures and see whether it reduces the residual risk below the risk appetite of the organization, and sees what associated costs are with it. It's of course important to see you could block an asset entirely from your infrastructure, but the business value might be very high, so that it wouldn't be the best solution. We created a decision tree to generate these courses of action. For instance, if the confidence of the decision and monitoring component was pretty low, then we'd say, okay, let's do a further investigation on this container. For future versions, we plan to have more complex scenarios again, such as ransomware attacks, and also take the decisions into account of what a human SOC analyst would do, and try to do some machine learning with that to see if we can mimic this behavior of the analyst. Finally, we have this course of action, but we'd like to apply it to our infrastructure, and we're using OpenC2 for this. In the automated decision engine, there is a OpenC2 producer, which produces OpenC2 commands, which sends it to the OpenC2 consumer that was discussed by Piotr. So what's OpenC2? OpenC2 is a machine-to-machine command and control language for cyber defense systems. It was established in 2015 by a group chaired by the NSA, and then later picked up in 2017 by Oasis. It's technology and vendor agnostic, and that's of course one of the aims in the PPS ASOP project as well. So what does this look like? On top, in red, we have the automated decision-making module that contains the OpenC2 producer, and that one sends an OpenC2 command to the infrastructure, which then automatically reconfigurates the infrastructure. In the columns on the right, you see the OpenC2 actions, and the bold ones are implemented. So deny, allow, start, stop, investigate. And we do that all based on the IPv4 connections that were established. As a conclusion, important innovations in this automated decision-making component are that we can take into account the business value of the assets when determining the best response. We also enumerate the possible responses to it automatically, and we make these containment decisions at machine speed and also immediately enforce them on the infrastructure. So back to you, Allard.
Thanks, Sebastian. Thanks for this very well explained part of the ASOP platform. Let's see if we can have the audience decide to pose some questions. But before we do that and let them think about it, I want to ask you a question. So you talked about the automated decision-making process based on course of action, situation, option awareness. But in some more difficult scenarios, you would an organization would want a human in the loop to make the decision. So how would this work in this automated decision-making part?
Yeah. That's an excellent question. During this project, we focused on doing these automated decisions automatically, because that's the aim here. Nevertheless, it's still possible to, for instance, instead of immediately sending out an OpenC2 command to your infrastructure, to, for instance, create a ticket to your IT department and give them the advice, okay, based on our idea of the infrastructure, the anomaly and the options, we would suggest this, please take a look at it. So it could also work as a piece of advice to your IT department.
Yeah, so it could also be part of the next iterations in the near future to build in such a more difficult automatic semi-automatic process.
Yeah, and also to build some confidence in this solution in the meanwhile.
Yeah. Thanks. Some other questions. I see the chat is empty, so hope it's all clear until now. Well, I might pose some new questions regarding the next part, which will be the video. So it's a command line level video. So it's the deepest in the technical parts we will end up. It's about 6 minutes, so bear with us, and we will show you how actually the platform works as of now using this unauthorized VPN scenario that has been explained earlier.
Hi, my name is Paul Wiper. I'm going to give a demo today of the PPS ASOP implementation. To dive right in, I'm just highlighting some of the different pods we use. For example, on the right is our monitoring infrastructure. In the bottom left, there's blue kind of hexagons. That's our simulation of the enterprise network, which is separated from. Finally, the pods at the top of the screen are what are simulating the network infrastructure, such as DNS and also the flow monitoring, and they're separated into microservices. Now we're going to jump across to Kibana. Kibana is where we visualize our data that is stored in Elasticsearch. Firstly, I'm going to show our logstash index, which is where the DNS queries come from DNS tap. It's stored in plain text, which Elasticsearch is great at, and we can see lots of detailed information such as the message query address, where the DNS query came from, and also detailed information about the authoritative forwarding and also the question and request that was made. Next we move on to the NetFlow. It is not just standard NetFlow v9, it's actually IPFix, the open standard, so it includes all the usual information such as source and destination IP addresses and duration and packet sent and port, as well as additional information to do with the Kubernetes infrastructure, which is not standard IPFix. So moving on to the demo now, we're going to log into our client that will later turn on a VPN. At this point, we're not going to turn on a VPN, and we're actually just going to boot up this very old school browser style application and do a bit of searching. We'll generate some traffic doing this, and we'll see that traffic reflected normally in our infrastructure. So right now I'm back in Kibana, and I'm actually going to select the correct namespace for the pod on one of our dashboards, and also select the pod name where we did that little search from. And then when I scroll down here, you'll see that we can even see the traffic to the IP address where Wikipedia is, which was what we were searching. Now we go to the monitoring and detection pod, and we can execute into it, and we can see the same data that goes into Elastic but in a slightly less graphical format. Remember that the reason the data is coming into this pod is so it can be evaluated against features that are made to detect virtual private network connections. So now we are going to go back to the pod that we generated some benign traffic in on Wikipedia, and we are actually going to turn on the OpenVPN with our already made configuration file, and then we will just ensure that that's actually turned on and that the interface is up. And now all of our traffic should be getting forwarded through that VPN interface and through a tunnel to another VPN server. So now if we move back to our monitoring and detection program, which is checking for any signs of VPN usage and parsing the data, we can see that it has in fact had a new anomaly triggered, which is for the usage of the protocol port combination 1194, typically associated with OpenVPN. And then we see the confidence, and we also see that it's successfully sent to the next stage. So the data about the anomaly arrives in Shuffle, where we have our workflows, and basically we're going to use our workflow to kind of automate what a SOC would usually do. The information about the anomaly arrives in Shuffle via WebSocket across like a RESTful API, and information such as the IP of the suspected pod, as well as the classification, so an explanation of what the report is about, also arrives at this end, and both are taken into the decision engine. Our decision engine will take into consideration different information it has about the suspected pod, and then it will decide on a action to take, and it will produce an OpenC2 command. Right now I have the executions open, so these are the events that have just happened, and I'm going to investigate the most recent one, and we can have a look. We can see why it's been reported for the reason of the port, and we can see that an action has been produced and also sent successfully. The action in this case was to deny ingress and egress traffic from the suspected pod. In the final stage here, behind the scenes of the OpenC2 consumer, we're actually translating the deny both command into the Kubernetes API to change the network policy so that traffic is stopped to and from the container. If we now go back and take a look at the pod which we were using to browse the internet and Wikipedia before, we will see, if we do a describe on this pod and see some of its metadata, we'll see that it has a brand new label which is deny both, which will mean that the network policy will take effect as this new label has been patched to the pod. This final command that I've run here is just to show the network policy in a bit more detail. You can see that ingress and egress is denied. Now finally, to do a quick check to see if the network policy took effect, I'll log back into that server and I'll try a quick ping on one of Google's servers, 8888. It's external, so they should be blocked. And no, it appears to be blocked, as we can see. So just to clarify, this is the same pod that we were on Wikipedia on before, and if we take a look in Kibana and we scroll down to some of the most recent data in terms of NetFlow, we can see that the network policy action is being to drop, and that's because of a Kubernetes network policy. So that's what we wanted. Thanks for your time.
Yeah, thanks for showing this, team, and thanks, Paul, for explaining this this very technical, detailed stuff so comprehensively. I hope it's clear for the audience. Now is room for the last question and answers. So if you have any questions, please drop them in the chat, and we can discuss them. I have the entire team here available to address these questions. So please. Let me check. Yeah, I have a question from Ralph Monen. Ralph.
Yes, hi there. Good little MVP/POC there with the VPN detection. One potential issue I see with this kind of automated decision making is, of course, that it could be leveraged by an attacker into a DOS. Especially when it comes to anomalies, it's pretty easy to spoof anomalies, so make it come from all kinds of source IP addresses, which are then automatically blocked. In what way can you distinguish between these kinds of real attacks and spoofed attacks that are meant to be a DOS?
Good question on the red race between the attacker and the defender. Piotr, could you answer this question, please?
Thanks. Yes, that's a question that keeps, of course, appearing. I guess there is a role for all the modules here. You can imagine also having a detector which tries to protect you against this kind of attacks, right? So if we have this extra information, if we have some kind of also external knowledge that can be pulled in from by the decision-making module, we could actually distinguish between them. Having said so, I don't want to say it's an easy or trivial task, and the question with software-defined whatever is always, aren't you creating more problems that you're solving? Yes, we hear it very, very often. It will remain a challenge.
Thanks for that honest answer. If there are any questions about the rest of the webinar until so far, it's also possible to ask this. I will wait a few seconds, and if no questions come, I will head on. So please raise them now. If there are not any, I think today we've shown you our ASOP approach, given the societal and the SOC challenges Nora started off explaining that are at stake. And we've shown you the platform, what the intention is, what has been built up until so far in the proof of concept. We've shown you that it uses a modular and interoperable way of working as a platform. It is vendor agnostic, so this means in the future you can bring in your own proprietary software that you're using or having as a service and plug it in. And it's all of this what has been developed is based on open source, but it is adjustable with the other modules. So. This is what we have built until so far in this proof of concept phase, but we are not there yet. So we are actually at the start of a journey, and we would like to take that together with those who are curious enough to see where we might end up with this platform. So next to me is Nora, and Nora, can you tell us a little bit more about the future ambition of what ASOP is and how others might collaborate with that and join in our journey?
Definitely. So thank you, Allard, again. So today I would like to wrap up by giving you an outlook of the ASOP consortium and how you could contribute to this. So first I would like to talk about the ASOP storyline, which we have developed in close collaboration with partners, network organization, but also end users. And we have defined the following 4 stages. And this is intended to find the road to market for the ASOP platform. So the first stage is the validation stage, in which we have developed the execution program. the phase 1 is actually the demonstration phase. That's the platform that it actually is feasible to develop the technology, which we have just shared with you. Phase 2, the third stage, is actually the operationalization of the technology, and which we will execute in close collaboration with partners. We will, as we speak, start with phase 2 in close collaboration with 4 partners, 3 vendors, and 1 managed service provider end user. So the first vendor is VMware, which will contribute to the abstraction layer. The second vendor is Cisco, which will contribute to the automation of security operations. And the third vendor is BizDesign, which will help with their model reason on the impact of detected threats on the business. Last but not least is the managed service provider KPN, who will reflect on the results of ASOP from an MSSP and a customer perspective. And finally, the third phase is about upscaling the platform with the knowledge application of end users and managed service providers. So in conclusion, with this strategy, which is derived from the ASOP ambition, the ASOP consortium wants to make an impact on the automation of security operations and grow into the knowledge center for automated security operation within 5 years. This brings me finally to my last point, and that is how you could contribute to the ASOP consortium. So when it comes down to phase 2, we think that with a mix of the collaboration that we have with the current partners, that we could actually take steps in developing the platform from a generic point of view. And of course with KPN as an end user. But if you want to steer this platform towards your industry, towards the domain knowledge, we could use your insight to do this. And for phase 3, as we speak, we are already shaping phase 3. We would like to get more involvement from vendors, MSSPs, to support the interoperability and the integration part. So please feel free to contact me for additional information. This brings me to the end of my presentation, but before wrapping up, I would like to thank the Ministry of Economic Affairs, which has made phase 1 possible. And now I'll pass over to my colleague, Allard.
Thanks, Nora. Yeah, thanks for this last part of explaining. Yeah, this actually ends this webinar. But before concluding, I would like to make my explicit thanks to the entire ASOP team that has been involved in this journey until so far. So thank you very much. And I would like, if you're still available in the audience, do a virtual clapping hands in Teams for them. I think that is in order here. So thank you very much. The content of this webinar and video will be, as I mentioned earlier at the beginning, published on the TNO website and during the next couple of weeks together with the video. Yeah, and thank you all for joining, participating. Very good questions, very good round. We are wrapping up a little bit early, but I think we're all set here. So have a great day and have a great summer, and I hope to see you next time. Bye.
Thank you for your attention.